Hello everyone. Today we have to see about the lecture video on introduction to the crystal physics. So previous class we have seen about some of the basics about the crystal physics. Now we have to see about the some basic concept of crystal growth and crystallography, which is most important for the modern technology development. What is a crystal? Crystal growth is the biggest ocean, and crystallography is the biggest ocean. Two different vast, the main distinguished research areas. So there are so many technical advancements can produce the modern technology devices. So what is, first of all, we have to know about the what is crystal growth, and what is about the crystallography. A crystal is or crystalline solid is a solid material whose constitution, atoms, molecules, ions are arranged in highly ordered microscopic structure, forming crystal layers that extends to all direction. So this is the process of making a crystal through laboratory, that is called as a crystal growth method. Now, naturally, that is the artificial crystals are present there. That is a quartz crystal. That images shows that artificial image of the um, crystalline quartz crystalline. That is naturally we have the diamond. Some of gemstones are naturally occurred with good morphological shapes. So that is, crystals is famous for this morphology. So that is the shape, that is the faces that will be faces that will reflect the light, that will the beauty of that natural crystals. So that is the building blocks. The every crystals are constructed through the building blocks, that is called as a fundamental building blocks, that is called as, technically it is basics of unit cells. So further coming slides we have to deep about the how the crystal formation is happened. Next is the crystallography. Crystallography is nothing but the scientific study of the scientific study of the crystal physics. That is nothing but the atoms and molecules arranged in different manner. So scientifically we have to, mathematically we have to identify the position of the atoms and molecules, which will be under the crystallographical methods. So what is the first, we have to know about the geometry of the and symmetry of the crystals. This is the base. The crystal and atoms or molecules are made up of the molecules. Crystals are made up of the molecules. So these are the atoms and molecules arranged in a periodic manner called as a crystal. That is the general information. So periodic means that is as a uniformity around the crystal formation. That will be called as symmetry of the crystalline materials. So there is a different type of crystalline materials will be there. The symmetry operations there. So symmetry operations is mainly classified by the reflection, rotation, and improper rotation, inversion, and identity. So there's a symmetry element is nothing but point of reflection, area of rotation. So area of rotation followed by the reflection, center of symmetry. These are the symmetry elements. So these are the symmetry element operated by the sum of operation, rotation, inversion, that will be given a repeated units of the atoms and molecules and uniformly through the material that forms a crystalline structured material. So that is the symmetry is mainly the categories into two. One is symmetry microscopic and macroscopic. Microscopic will be a symmetry element called by rotation, mirror, and inversion, and microscopic called as a screw axis and glide reflections. So these are the acting point that will be based on that position of acting point, it will be differed. So external morphology is it is classified as the macroscopic, that will be classified as a point group of the material, point group of the crystal. Microscopic will be inside the internal arrangement of atom, that is called as a microscopic cluster, technically named as a space group. This is the picture of, you can see the picture of that morphology of the crystals, that will be classified by the different symmetry element. The dotted lines and the red color axes are denoted by the rotation and inversions, and the grids and phases. How it is mirror planes are every crystal morphological, that is the shape is nothing but the morphology of the crystal. So based on the morphology it will be classified. The symmetry of the elements, that is point group of the material, will be the crystal will be find out that. So next we have to see about the Miller indices. Next we have to find the Miller indices. Miller indices is the basic concept, that it will be identify the what are the phase will be in the crystalline materials, and how many members of the crystalline material will be there based on the symmetry. So we have to say, first we have to take the that is the, we have to see the drawing of the Miller indices. There is a pictorial representation, that is if it is a crystal has been drawn on the 3D three-dimensional images. Next you have to draw the straight line around the faces that will cut into the three differential axes. for simplification, I can identify that is the two-dimensional picture. So that is intersecting on the point on x and y b will be the main that is the reciprocal that is the intercepting point. The reciprocal of intercept will be called as a Miller indices, will be converted into clear fractions, and we get the Miller indices of the particular phases to identify which phase. And there is a crystal, there is a physically there is a number of planes in the crystals. That's why we need to know how the what is the phase, what is the identify the particular phase through these Miller indices. Miller indices is mainly important for the identification of phases, and it will be used for structure property relationships. Next we have to see about that stereoscopic questions. So stereoscopic conversion is nothing one of the method we have to identifying the three-dimensional object into the two-dimensional object. So in this class, similarly the Miller indices can be classified, will be denoted by that after finding of the Miller indices, the stereoscopic question may indicate the three-dimensional object orientation into two dimensions. That is called as a stereoscopic position and stereogram. In this class I have stopped. In next class we have to see about the how the three-dimensional crystal will be projected on a two-dimensional picture, two-dimensional plane, and identify the Miller indices, how it will be donated, will be used for how it is used for various application in the device fabrication. Next class we will see in a detailed manner. Thank you.